Friends, if there's something in the world that consistently keeps progressing, it's time, which is why it's said that time waits for no one. You can stop yourself, pause your watches, but no matter how hard you try, you can't stop time. Perhaps that's why time is considered the most precious thing. This time, like we experience daily in our lives, is quite a mysterious concept. In this universe, among all things, time is the most distinct. Unlike matter and energy, time doesn't have a physical presence in space. Yet, it's truer than anything else. Even if there's nothing else in this universe, only you cannot deny the existence of something we call time. Time is so normal for us in this universe that we hardly ever think about it. What is it, after all? In this video, we will attempt to understand time from a scientific perspective, to answer the question of what time really is. Don't go anywhere. Stay with me until the end of this video. Friends, if someone asks you what time it is, you immediately look at your watch and tell them the exact hour and minute. We typically consider these ticking clocks as time. However, clocks were not always there. In ancient times, time was measured by the rising and setting of the sun, the changing phases of the moon, and the cycles of the weather. With changing times, the measures change too. Today we use electronic clocks and even atomic clocks to measure time. But these are tools for measurement. Time itself is something different. So, what is time? If we observe, we see that in this universe something is constantly in motion. Things are always changing, and this change never stops, and this change is always reversible. It means that what has been lost cannot be regained. We sometimes wish we could go back and change our past decisions, but we all know that it's not possible. If we look at it this way, there is a flow, a one-way motion that keeps moving forward. In the language of physics, we can call it the arrow of time, which always moves from the past to the future. It is never the case that a broken eggshell magically reassembles itself, or that tea, milk, and sugar once mixed return to their original states. This never happens because a fundamental property of the universe is that disorder always increases. The universe always moves from order to disorder. If we create an arrow between order and disorder, it always points toward disorder. In the language of physics, this increasing disorder is known as entropy. This fundamental property of the universe defines time and its direction. In a way, we can say that perhaps the universe's ever-increasing entropy gives rise to the feeling inside use that we call time. This raises the question, time is merely a subjective perception that we experience. So can we say that time is just an illusion based on these observations? Well, no. Some scientists suggest that time might be an emergent property of the universe. Think of it like understanding the properties of atoms in a body of water through atomic theory. Atomic theory can describe which elements make up the atoms in the water, the bonds between them, and their chemical properties, among other things. But it doesn't tell us about the waves in the water. Waves are an emergent property of the atoms in the water, generated by their interactions. Likewise, time could be an emergent property of the universe, created by the activities happening within the universe. Just like waves are real in the water, time is real in that sense. So, without considering time in our scientific theories, our mathematical equations wouldn't work effectively. Like Einstein's famous theory, the theory of general and special relativity. It includes time as a fourth dimension in three-dimensional space, and this theory provides a precise answer to questions that arose due to some recent discoveries. For example, how does the speed of light remain constant in every situation? I mean, why does the speed of light from one end of the light to the other remain the same for a moving and a stationary observer? In other words, if a person tries to measure the speed of light while moving in the direction of the light, it should be relatively less. And if someone tries to measure the speed of light while moving in the opposite direction, it should be relatively more. However, it doesn't work this way. The speed remains the same in both situations, and this is not just a critical assumption, but has been experimentally proven. But how is this possible? Albert Einstein explained this by saying that this happens because, in order to conserve the speed of light, time slows down and space contracts. Now, this can be quite confusing. Okay, let me explain. Einstein's point was that time does not pass at the same rate everywhere. For a moving observer, time moves slower compared to a non-moving observer, and that's why the speed of light remains constant for them. Imagine measuring the speed of something using the formula distance divided by time. In the case of light, it's about 300,000 kilometers in 1 second. Now, think about two observers who are trying to measure the speed of light, but they are trying to increase its speed. Due to their motion, one observer's time is passing slower compared to the other. This means that their 1 second is slightly longer compared to 1 second of the other observer. Since the duration of a second is longer, light comfortably covers a distance of 300,000 kilometers without any problem. The faster an object's speed, the slower its time. So that's why the speed of light remains constant in every situation. In other words, time behaves differently at different places in the universe, not just due to motion, but also due to gravity, according to Einstein. This means that time moves slower around massive stars or black holes. Einstein called this effect time dilation. This concept was so astonishing that it was challenging to believe. Time, as we used to think, doesn't pass at the same rate for everyone. If a person travels at a high speed, their age will age much slower because time slows down for them, and people on Earth will age much faster. In fact, this theory also suggests that if an object were to travel at the speed of light, time would come to a halt for that object. Although practically achieving this is not possible, only small particles like photons travel at the speed of light. This was the theory, but has time dilation been observed in any practical experiment? Yes, it has been. In 1971, an experiment was conducted in the United States. In this experiment, 3 atomic clocks were taken, and one clock was put on a plane flying east, and the other was put on a plane flying west, while the third one remained in the lab on the ground. After these 2 planes completed their journeys and returned to Earth, the clocks were compared with the one that stayed on the ground. It was found that there were differences in the times of all 3 clocks, and these differences were exactly as predicted by Einstein's theory. This meant that time dilation is real. In a similar manner, in one experiment, when 2 previously synchronized atomic clocks were placed at different altitudes above the Earth's surface. For some time, there was a difference in the time between the clock closer to the ground and the one at a higher altitude due to Earth's gravitational pull. It ticked more slowly. Not only that, even the atomic clocks present in GPS satellites today take this time dilation factor into account. If this were not done, your mobile or car's GPS wouldn't accurately determine your location. So, that's it for today's video. Hope you enjoyed it. Please subscribe for more videos like this.